Hello everyone. In this video, let's learn how we can design a FSM which detects a sequence of 10110011. So we'll go a little bit more complicated than the previous videos. If we know how to do this, we can deal with any FSM sequence detector. So looking at 10110011, so we have 8 bits, we need 8 states. So let's call them S0 through S7. So we know up to 4 states, we have 2 bits for each state. More than 4 up to 8, we need 3 bits per state. So S0, let S0 be 000, S1 be 001, S2 be 010, and S7 111. So let's start by the state diagram. So we have S0, S1, S2, and S7. So first, let's assume the user is entering the correct sequence without any mistakes. So that means the user will enter 1011, 0011. So at S0, if we enter 1, we go to the next state, which is S1, and the output will be 0. At S1, if we enter 0, we'll go to the next state, S2, the output will be 0. S2, if we enter 1, we go to the next state, S3, the output will be 0. And let's write here, from S0, if we enter 1, we go to S1. So here we detected 1. At S2, we detected 1 and 0. So this is 1, 0. At S3, we detected 1, 0, 1. Now at S3, if we enter another 1, we go to the next state, S4. The output is still 0. So this is 1, the output is 0. And then at S4, we detected 1, 0, 1, 1. At S4, if we enter another 0, we go to the next state, S5. And this is 0, the output is 0. And then at S5, we detected 1, 0, 1, 1, 0. From S5 to S6, if we enter another 0, so that's 0, the output is 0. And then at S6, we detected 1, 0, 1, 1, 0, 0. At S6, if we enter 1, we go to the next state, S7. That's 1, the output is 0. At S7, if we enter 1, where do we go? So we don't go to S0, we go to S1 because here we have 1. When we enter 1, we go from S0 to S1. Also at S7, when we enter 1, we go back to S1 and then we can continue the sequence. So at S7, if we enter 1, the output will be 1 because we completed the correct sequence, and then we'll go to S1. Now, what happened if the user entered the wrong bits? So first, instead of entering 1, the user entered 0. So at S0, we can only remain at S0 and start over. So we remain at S0, we enter 0, the output is 0. Now we are at S1, we are supposed to enter 0, but we want to see what happened when we enter 1. So we already have 1, we're supposed to enter 0, let's say we entered 1. So what happened? If we discard this 1, our sequence starts with 1. So we can remain at S1. So this is 1, the output is 0, and then we can continue. So now we are at S2, we have 1, 0, we're supposed to enter 1. We want to see what happened if we enter 0. So we are already at 1, 0, and then we entered 0. So we have a couple options. We can remain at S2, we can go back to S1, or we can go back to S0. So the way I look at it, let's start discarding. From the left, if you discard this bit, we'll be left with 0, 0. Our sequence starts with 1, 0, so we cannot make the sequence right. So let's see if we can discard another bit. We'll be left with 0. Also, our sequence starts with 1, so we have to discard everything and go back to S0. Let me make some room. So S2, if we enter 0, we said we go back, we discard everything, and we go back to S0. So this is 0, the output is 0. Now we are at S3. We have 1, 0, 1. We are supposed to enter 1. But we want to see what happened when we enter 0. So we're supposed to enter 1, but let's say we entered 0. Now let's see. Can we discard this 0 and make the sequence correct? No, because we'll be left with 0, but our sequence starts with 1. What happened when we discard another 0? We'll be left with 1, 0. 1, 0 takes us to S2. So that means from S3, if we enter 0, we go back to S2 and continue to make the sequence right. So this is 0 and the output is 0. Now we are at S4. We are supposed to enter 0. But let's see what happens if we enter 1. Also same idea, so let's start discarding from left. If we discard this, we'll be left with 0, 1, 1, 1. We cannot make the sequence right because our sequence starts with 1. If we discard this, 1, 1, 1, we cannot make it correct. If we discard this, we cannot make it correct. If we discard this, we'll be left with 1. Yes, we do start with 1, and this will take us back to S1. So from S4, we go back to S1. If we enter 1, the output is 0. Now we are at S5. We are supposed to enter 0. Also, let's see what happens if we enter 1. Also, let's start discarding from left. If we discard this 1, we'll be left with 0. 1, 1, 0, 1. Our sequence doesn't start with that. So if we discard another 0, we'll be left with 1, 1. This doesn't make the sequence correct. So let's discard another 0. We'll be left with 1, 0, 1. Yes, our sequence starts with 1, 0, 1 and continue. So where's 1, 0, 1? 1, 0, 1 is at S3, right? Because we enter 1, 0, 1. So that means from S5, we go back to S3. We enter 1, the output is 0. Now we are at S6, we are supposed to enter 1. Let's see what happens if we enter 0. Feel free to pause and try to see where do we go. We can remain at S6 or go back to any previous state. So if we discard this one, we cannot make the sequence right because we start with 0, but our sequence starts with 1. If we discard this, we cannot make it right. If we discard this, 1, 0, 0, 0, we cannot make it right. If we discard this, we cannot make it right because our sequence starts with 1, we are left with zeros. So in this case, we have to discard everything and go back to S0, to the initial state. So we entered 0, the output is 0. Now we are at S7. S7, we detected 1, 0, 1, 1, 0, 0, 1. We are supposed to enter 1 to complete the sequence, but let's assume we enter the wrong bit, 0. Also same idea, start discarding from left. We cannot make the sequence right because we start with 0. Discard another bit, we cannot make it right. Another bit, we cannot make it right. Another bit, we cannot make it right. Another bit, we are left with 1, 0. Yes, our sequence starts with 1, 0. 1, 0, which state is we detect 1, 0, S2, right? So that means from S7, we go back to S2 if we enter 0. So let's do it this way. We enter 0, the output is 0. So this is it. Now let's clean it a little bit. So really, we didn't need these, but it's good to have them so you know how to transition. So next we can make the state transition table. So in the state transition table, we have the current state. We have the input, let's call it X. And then we want to figure out the next state. And also let's see the output, let's call it Z. So let's call our current states Q2, Q1, and Q0. And then the next state Q2 plus, Q1 plus, U0 plus. So let's list our states first. So we have 0, 0, 0. And then for every state, for each state, the user could enter 0 or could enter 1. So we write it twice. This is for S0. So I'm going to quickly complete it because it's the same idea. Okay, so now let's fill the next state. So if we are at S0 and we enter 0, where do we go? We remain in the same state as 0, which is 0, 0, 0. And then the output is 0. If we are at S0 and we enter 1, we go to the next state, which is S1. So this will be 0, 0, 1. And the output is 0. If we are at S1 and we enter 0, S1, we enter 0, we go to S2. S2 is 0, 1, 0. The output is 0. If we are at S1 and we enter 1, so according to this state flow diagram, we remain at S1. So S1 is 0, 0, 1, and the output is 0. If we are at S2 and we enter 0, S2, we enter 0, we go back to S0, which is 0, 0, 0, and then the output is 0. If we are at S2 and we enter 1, so we see we go to S3, S3 is 0, 1, 1. So next, if we are at S3 and we enter 0, S3 we enter 0, we go back to S2, S2 is 0, 1, 0, and then the output is 0. If we are at S3 and we enter 1, we go to the next state, S4, S4 is 1, 0, 0, and the output is 0. If we are at S4 and we enter 0, so we go to S5, S5 is 1, 0, 1, and the output is 0. If we are at S4 and we enter 1, S4, we enter 1, we go back to S1. S1 is 0, 0, 1, and the output is 0. If we are at S5 and we enter 0, S5 we enter 0, we go to S6. S6 is 1, 1, 0, and the output is 0. At S5 we enter 1. S5 we enter 1, we go back to S3. S3 is 0, 1, 1. The output is 0. So you know how to fill the rest. I'm gonna just fill them up really quick. Lastly, S7 and we enter 1, we go back to S1 and we complete the sequence. So the output will be 1, and S1 is 0, 0, 1, and the output is 1. So this is it. Next, if we can design the circuit using any type of flip-flops. So how many D flip-flops we need? We saw that in previous videos. We can do log base 2 of the number of states, which is 8. So this will give us a 3. So we need 3 flip-flops. If you need, let me know in the comments below. We can make another part using any type of flip-flops that you suggest, D, T, JK, or any type of flip-flops. Thanks for watching. I hope this was helpful.
Enjoyed this video? Subscribe to the Computer Engineering Notebook for more tutorials on computer architecture, embedded systems, and hardware design. And hit the bell to catch the next one.